This is part 2 of the lesson 8.2 tutorial on modeling and solving linear systems. This tutorial involves or goes through example 3 and the key ideas from the lesson. For the final example, we're given the information that a movie theater charges $11 for an adult ticket and $8 for a children's ticket. 240 people total attended the first movie, and the ticket sales totaled $2,370. We want to know how many adults and how many children attended the show and what system of linear equations we could use to find that, and then actually solve it for how many adults and how many children were there. So the first thing we need to do is define the variables. So we've got to pick two variables and what they are going to represent. So here I've chosen A to represent the number of adult tickets and C to represent the number of child tickets. This is what the question's asking us to find, is how many adults and how many children attended the movie. So that gives us a clue as to what our variables should represent. So first we can write an equation to represent the number of tickets sold. However many adult tickets were sold, so A, plus the number of children's tickets sold, so C, has to add up to the total number of tickets sold, which is 240. Then we want to write an equation to model the total ticket sales. So we're going to write our variables in terms of the ticket prices. The adult tickets cost $11 per ticket, so the total amount of money that the theater would make off of adult tickets would be $11 times the number of adult tickets. Plus, we want to add on to that the total that they make from the children's tickets. So we're going to go 8 times the number of children's tickets. The total amount that they make then is $2,370. So now we have two equations. They each have one of each of the variables, and so these two equations will form a system of equations. To go ahead and solve that, you can graph each equation, but you have to have one of the variables isolated. So we're going to take each equation and isolate it for A. The first equation is going to equal A is equal to 240 minus C. And the second equation, when you isolate it, you're going to have A is equal to 2,370 minus 8C, all divided by 11. So we will take our two equations that we've isolated for A, type them into our calculator using X instead of C, and our Y is going to be instead of A, and our graphs will look like this. When you go and find the point of intersection using second trace number 5, you'll find that the intersection is X equals 150 and Y equals 90. That's the point of the intersection, 150, 90. And what that represents is, because our X was the number of children's tickets, C was equal to 150 children's tickets sold, and our Y was our A value, so we had a total of 90 adult tickets sold. All right, so in summary for lesson 8.2, let's look at some of the key ideas. The first one is, when modeling a word problem, assign variables that are meaningful to the context of the question. For example, let C represent the cost, and maybe let T represent time. That way, it's easier to keep track of what those variables are representing. The second point is draw a diagram or make a table of values to help visualize the problem. This can often help you if you're stuck and don't know how to get started as well. The third point is, a situation that involves quantities that change at constant rates can be represented by a system of linear equations. Example, 2 tanks are being filled at constant rates, 20 liters per minute and 25 liters per minute. When you see a constant rate, then you know it's probably a linear equation. And the last point is, you can write the equations of a linear relationship in slope y-intercept form, or y equals mx plus b, right away if you know the initial starting value in the situation, which is going to be your y-intercept, and the constant rate of change, which is going to be represented by the slope. If you know the start and end values only, and not the slope, you can use those start and end values to calculate the slope for your equation. And once you have the equations, you can then solve them by graphing, just like we did in Lesson 1. The practice questions that you can do to help you practice your skills for this section are on pages 440 to 445 in the McGraw-Hill Ryerson Mathematics 10 textbook. These are recommended practice questions, but don't forget, you can always do more if you need more practice. And check your answers with the back of the book to make sure that you're on the right track. Thanks for watching.